अब देखो, सबसे पहले इसमें बहुत इस चैप्टर में जो जो टॉपिक हम लोग पढ़ेंगे, फर्स्ट टॉपिक शुड बी अबाउट measurement of heat and measurement of temperature. Measurements of, first we'll start temperature, measurement of heat, measurement of temperature and measurement of heat. First thing, measurement of temperature is thermometry, and measurement of heat is calorimetry. Calorimetry. Then we do the thermal expansion concept. Thermal expansion. Then we have transfer of heat. Then we have transfer of heat. So today let's start with measurement of temperature that we call as thermometer. First of all, there are few things that you should understand. What is heat and uh, what is heat and what is temperature? So heat is a form of energy. What is heat? So heat is a form of energy which can flow from one body to one body to other, one body to other. How it will flow, that depends upon another factor that is called as temperature, like how heat will flow. So heat flows from one body, that is body at high temperature, to other body, that is body at low temperature. That means temperature is that factor which decides in which direction heat is going to flow. Okay, Neil?
Okay.
So temperature is basically the skill, or that the physical factor which determines the direction of heat flow. So we can write as the definition of temperature also. The definition of temperature is basically the physical factor, the physical factor which determines the direction of heat flow. The direction of heat flow. In as far as heat is concerned, we use unit like calorie, that is CGS unit, and we use joules, that is SI. How we can convert it? So we can say 1 calorie is equals to 4.2 joule. That is the conversion factor between calorie and joule. Temperature is measured as in three type of units. How we measure the temperature, that first you understand. When you measure temperature, first we decide what is the thermometric property. Just a minute.
Yes, sir, done.
Yeah, okay, sorry. So first we think about thermometric property. What do we mean by saying thermometric property is actually that property which depends upon temperature. The property of a matter which varies linearly linearly with temperature, that we call as thermometric property. So thermometric property is basically that type of property which is varying linearly with temperature. You can use any type of property, like you can use length, you can use volume, you can use pressure, you can use resistance. These all are the thermometric property that varies linearly with temperature, and so they can be used as temperature thermometer, that is temperature measuring device. Understood?
Understood, sir.
So what type of, and then after thermometric property, this next step is calibration. Calibration, like normally we use mercury thermometer in our home to measure the body temperature. So in that mercury temperature, what happens? The volume of the mercury changes, and by the measuring the volume, you can find the what is the exact temperature of the body. Now, calibration is that how the scales you are choosing. That is here some scales are chosen. Some scales are chosen here. Here to scale, first we keep a lower fixed point that we call as LFP, lower fixed point. This is basically estimate. Okay, that is called lower fixed point. And how we choose lower fixed point is that temperature that is also melting point of ice. It is melting point of ice. Then we take a upper fixed point. It is basically it is upper fixed point, and that is basically boiling point of water. So whenever you want to choose a scale, we first choose two points. One is lower fixed point, upper fixed point. And then you divide some interval between them. Like if I say that, let's suppose this is the scale I am having. Let's draw two scales. So if I say this is the scale that I have used, here I'll use lower fixed point. Here I use upper fixed point. That will be in all kind of scales that we are using. And then first we choose these 2 points, and then we divide the scale into some subscales, that is the lines, the intervals that we are dividing the difference between lower fixed point and upper fixed point, like this. So if it is a Celsius scale, if it is a Celsius scale, we also sell a centigrade. Then lower fixed point we keep as 0 degrees Celsius, and upper fixed point we keep at 100 degrees Celsius. And between 100 to 0, here the intervals, we can say that range of temperature, or intervals also you can say. This here is, here range is 100 minus 0, that is 100. If you take a Fahrenheit scale, let's suppose I take Fahrenheit Fahrenheit scale. So here the lower fixed point we keep as 32 degree Fahrenheit, I think. 32 degree Fahrenheit. And upper we fix as 212, that is boiling point of water, 212 degree Fahrenheit. And the range here that you are taking is 212 minus 32, that is 108. And if you take the SI that we call as Kelvin scale, Kelvin scale, lower fixed point is 273 Kelvin, and upper is here 373 Kelvin. Here also the range is 100. Understood?
Yes, sir. Understood.
Have you copied whatever I have taught so far?
No, after that thermometric property, I didn't ask. No.
Okay, you're right.
Yeah, sir, could you scroll down?
Here, a Kelvin scale that you can see, this is basically called as SI unit, right?
Oh, okay.
Yes. Done?
Yes, sir. Done.
Okay. Now, what is the principle that we will follow here that we call as principle of thermometry? It is called that any scale, whatever scale you are taking in any scale, the whatever is reading, that is the value that it reads as temperature minus lower fixed point divided by the range. Range, it means uh, or I can write in formula form also. Range means we can say upper fixed point minus lower fixed point. This will always remain constant. It will not change. Like in scale, in let's suppose Celsius scale reading is C. So C minus lower fixed point is 0 degree. C minus 0, upper fixed point is 100 minus 0. It should be equal to the Fahrenheit scale reading is F, let's suppose, and lower fixed point is 32. F minus 32, 212 minus 32, that is 180. Kelvin, let's suppose reading is K minus lower fixed point is 273 and upper fixed point is 373 minus 273. This is the formula that we can use. C by 100, this is F minus 32 by 180, and this is K minus 273 by 100. You can also simplify this 25 times, 29 times, 25 times. So finally, we can write C by 5 is equals to F minus 32 by 9, and that is equal to K minus 273 by 5. So if you, this is the relation between different scales. And if you want to convert Celsius into Fahrenheit or Fahrenheit to Celsius, you can use this formula. Like if I wish to change Celsius into Fahrenheit, okay, then we can only write C by 5 is equals to F minus 32 by 9. That means if you want to find the Celsius value when some Fahrenheit value is given, so you can write here 5F minus 32 by 9. Also, I can say C equals to 5F by 9 minus 160 by 9. It looks like an straight line equation, like y equal to mx plus c, y corresponds to c, x corresponds to f. And the slope is positive, intercept is negative. That means if you take a Celsius and Fahrenheit graph, then intercept will be negative. So it will strike like this. This type of graph you will get. This is the intercept, that is negative minus 160 by 9, whereas the slope of the graph is positive and the slope is equal to 5 by 9. That is the slope. So slope means always you use tan theta, that is equal to 5 by 9. Understood, Neil?
Yes, sir, understood.
Please complete writing.
Okay. Yeah, sir. Could you scroll down?
Should I scroll?
Yes, sir. Yes. Yes, sir. Done.
Okay. After this, we have to understand the concept of thermal expansion. Thermal, as the name suggests, it is basically increase in dimension with temperature. Increase in dimensions of a body, or we cannot say only increase, we should say change in dimension, because sometimes it can decrease also. Change in dimensions of a body with temperature. Why, you may ask, why the dimension changes? So we can say that with increase in temperature, with increase in temperature, the average separation between molecules increases. They becomes separate from each other. Like if they at low temperature molecules are like that, let's suppose it is at temperature T, then at increase it might go at temperature T plus delta T, and they can also go close at less temperature T minus delta. So due to this, we can say that there is a change in dimension. There is change in dimensions. First type of change that we observe is linear dimension, linear expansion, we can say. Here the length is changing. This is linear expansion. So it is increase in length
increase in length with temperature increase. If you have one wire that is having length L at some temperature T. So if you increase the temperature, then slightly length also increases, that is L plus delta L it becomes at a temperature T plus delta T. Are you understanding, Neil?
Yes, sir. Yes, sir.
So here it says that delta L is proportional to the actual length of the string. How much will be the extension, how much will be the length increase, that depends upon two factors. It depends upon L, that is original length, original length, and also it is proportional to the temperature change, how much you have increased the temperature. Okay, that is, we can say that is change in temperature. If I combine these two, then what I get here, delta L is proportional. Delta L is proportional to L delta T. So if I put a proportional constant that also looks like this only, but this is alpha. Alpha L delta T. So here we can say that alpha that we have used is a constant. It is a constant, and that is known as coefficient of linear expansion. Coefficient of linear expansion. Linear expansion. And if you want to know delta L is actually, let's suppose T1 is the final length, L1 is the L1 is the initial length. If I assume that L1 is original length, that is initial length also you can say, and let's suppose L2 becomes final length, that is increased length. So delta L is basically L2 minus L1, and alpha initial length is L1 into delta. L1 you can take that side, so it becomes L2 equals to L1, you can take common 1 plus alpha delta T. So this is also a good formula to find the final length L2. You need to L1 should be multiplied with 1 plus alpha times delta. In other words, if you want to find alpha, that also you can find from this. It is change in length L2 minus L1 divided by initial length L1 into delta. Do you understand, Neil?
Yes, sir. Yes, sir. I understand.
Yeah, it is right.
Okay.
Should I scroll?
Sir, just 1 second.
Okay.
Yes, sir. Could you scroll down?
So you understood the concept of formulas?
Yes, sir. Understood.
Second type of expansion is superficial expansion. We can also say that as area expansion, superficial expansion. Here area increases. This is basically increase in area. Now let's understand it in detail. You have one, let's suppose square of side L. This is at temperature T. When you increase the temperature, its length slightly increases. It becomes L plus delta L. And this is also increases L plus delta L. L plus delta. And this is at temperature T plus delta T. So here what you can see that area A is L square. And here area will increase. Let's suppose area increases by A plus delta A and it becomes L plus delta L square. So if we write A plus delta A, it is L square. I can break it A square plus 2AB, 2L delta L plus this is delta L square. Delta L is very small. So delta L square will be also very small. So this term we can neglect. So we can write A plus delta A is equals to L square plus 2L delta L. As A and L square are same, so A and L square we can cancel. So we can find the formula of change in area is 2 L into delta L. We know the delta L already we have found, that is alpha L delta T. So in place of delta L, I am going to use that. This becomes 2L and this becomes alpha L delta T. We can also write it as 2 alpha L square delta T. Now this L square is basically A. So change in area is 2 alpha into original area delta T. 2 alpha is a constant here that we often write as beta, beta A delta T. It means that delta A actual formula is beta actual area into delta T. Now you might ask what is beta here. So beta is nothing but is called coefficient of superficial expansion or area expansion. Coefficient of area expansion. If you wish to find the formula for beta, it is basically change in area delta A by original area into delta T. If area initially was A1 and now it becomes A2, so change is A2 minus A1 divided by initial is A1 only into delta T. And also you can find the final area A2 by the formula A1, just like L1, L2 you can use, but coefficient you have to change. It will be 1 plus beta into delta. And also in place of 2 alpha, I have written beta. So I can say that the beta value is 2 times of alpha. That is coefficient of area expansion is twice the coefficient of linear expansion. Understood, Neil?
Yes, sir.
Okay, please write about superficial expansion also. Are you done, Nidhi?
No, sir. No. Yes, sir. Could you scroll down?
Done?
Yeah, sir. Just 1 second. Yes, sir. Done.
Third type of expansion is that we call as volume expansion. Volume expansion. Volume expansion is basically increase in volume. Increase in. So let's suppose you have a cube whose sides are all L. This all are L. So its volume is L cube. It is at temperature T. Now with slight increase in temperature, let's suppose the expansion happens and now the sides becomes L plus delta L. So now the volume will be L plus delta L cube, and that happens at temperature T plus delta T. And this volume also increases. We write V plus delta V. That means our equation will be now V plus delta V is equal to L plus delta L cube. If I use here A plus B Q, A plus B whole cube formula, it becomes A cube plus B cube plus 3A square B, L square delta L, plus 3AB square. So 3 L delta L cube. But delta L cube or square actually, delta L square, this both are very, very small. Very small. So these two we will ignore. So if we ignore that, it becomes V plus delta V is equals to L cube plus 3 L square delta L. And V and L cube are equal only. So I can use delta V equals to 3 L square. Delta L formula we know is alpha L delta T. So I can also write here 3 alpha L cube delta T. So this delta T, this 3 alpha is a coefficient and L cube is equal to V. So I can also write here delta V equals to 3 alpha V delta T. Now 3 alpha is itself a coefficient that we can write as gamma. So delta V equals to gamma original V into delta. So here this gamma that is equal to 3 times of alpha is coefficient for volume expansion. Coefficient for volume expansion. That is gamma for you. Also, if you want to find gamma, is change in volume by original volume into delta T. Or we can write change in volume is V2 minus V1 divided by V1 into delta T. If you want to find the final volume, same formula, V1 1 plus gamma delta T. And as you say, gamma is 3 times of alpha. So if you need to write the ratio, alpha ratio beta ratio gamma is always 1 ratio 2 ratio 3. Understood, Neil?
Yes, sir. Understood.
Yeah, right about this.
Yes, sir. Good is going on.
हेलो हाँ
Yes, sir.
हाँ हाँ ठीक है हम रखते हैं ओके क्लास के बाद बात करते हैं ओके या स्कूलिंग मिस्टेक
Okay, sir. Yes, sir. Done.
Okay. Okay, we'll continue this in the next class. Okay.
Okay. Okay. Thank you,
Bye.
sir.
Thank you.
Bye. Yes. Thank you.